In this video, we are going to talk about dimension analysis. So, what is dimension analysis? Dimension analysis is just basically the relationship between the physical quantities with the help of the dimensions and the units of the measurements. So, let's say maybe you have a 20 kilometers per hour. You want to convert this one into meters per second. So, by the use of dimension analysis, it can help us to convert this into meters per second. Now, using dimension analysis, what we do is we have to write the 20 kilometers here, then we have to write the hour here. So we say in 20 kilometers there's 1 hour. Now, I want to convert this one into meters. So what I'm going to do is that I'm going to say that in 1 kilometers, how many meters are there? There are 1000. Meaning at this time now, I can see that kilometer and kilometer will go. Now let's convert the hour to seconds. We know that in 1 hour, how many seconds do we have? But we can start with minutes. We have got 60 minutes. Now from here we can also say that in 1 minute, how many seconds do we have? We have got 60 seconds. So as we can see from here, we can see that the hour and hour can go, the minute and minute can go. Then we are going to say that a 20 times a 1000, everything divided by 60 times 60. Okay, so 60 times 60. So the answer I'm getting is 5.5555 meters per second. So this is how we can use dimension analysis to convert kilometers into meters. Okay, this is the same. If we want to convert, maybe we want to convert, we have 200 or maybe 2000 meters per seconds. We want to convert this one into kilometers per minute. Okay, kilometers per minute. So using dimension analysis, this is going to be a 2000 meter in 1 second. So we are going to say that in 1 meter, okay, or we say in 1 kilometer, how many meters do we have? We have got 100 meters, 1000 meters, sorry. And then seconds, converting seconds into meters, we are going to say that in 1 minute, how many seconds do we have? We have got 60 seconds. So from here we can see that meter and meter can go, seconds and seconds can go. So what we are going to have is going to be a 2000 divided by or we can say a 2000 times a 60 divided by what? 1000. So I'm getting 120. So it's 120 kilometers per minute. Okay, so it is very simple for us to convert from kilometers to meters, meters to kilometers. Okay, now what we need to understand is that the main important thing under dimension analysis is we are dealing with the physical quantities. So the only units which we have to know is we are going to be concentrating more on mass. Then we have the length. We also have the what? The time. When I talk about the length, I'm talking about the meters. Now, when it comes for the SI units, we know that mass, it is in kgs. Then the length is in meters. The time, it is in seconds. So these are the basic units. All the units, they are coming from mass, length, and time. Okay. Now, when it comes for dimension analysis, what you need to understand is that when you see the mass, we know that mass is going to be in kgs, meaning that this we have to represent it with this. We have to represent it with what? Capital M. When we see the mass M, we have to represent this one with the L. then we put this. Then when we see the time, okay, which is in seconds, in short, when you see the seconds, which is time, we put t, then we represent it by this. Okay, that is very, very much important. Okay, now from here, let's go direct to the practice questions. We see how we can solve questions. Okay, so I have got my first question here, which is saying, or let's first do this one. The first question which I have here is saying, using your knowledge of dimension analysis, obtain an expression for the time period of a simple pendulum given that the time period depends on other quantities like mass of the bulb, the length of the string of the pendulum, and the acceleration due to gravity at the place where the pendulum is suspended. Now, when getting the expression, in this case we want to get the expression of the period. Okay, now it is very, very much important for us to know that the first rule which we have to apply for us to find the expression which they want us to find is very simple. Okay, what we need to understand is that when you write the period, we know that period, with the moment when you write the period, you need to like to say this symbol. Okay, this symbol is for proportion. So we know that we want to get the expression in terms of the mass, so I'm going to put mass, the length, and the g. Now, where there is the proportion, I'm supposed to replace it with equal to, I'm supposed to replace it with what? Equal to k. So where there's proportion, I'm supposed to replace with this part. The reason why I'm putting k is constant. We really don't know if maybe we had a constant. Okay, so what I'm going to do is I'm going to say that t is going to be equal to k. Now I'm replacing the whole of this part with equal to k. Okay, that is the first step. Now after replacing this with equal to k, meaning that this now is going to be the mlg. But what we need to understand is that we don't know the powers of the mass, we don't know the powers of the length, also the power of that, of what? The g. So what we need to understand is that we are going to put these guys, we are going to replace it with what? N letters. So I'm going to say that this is going to be x, this is going to be y, this is going to be z. So my goal now, this is going to be my formula, but my goal is to find the value of x, y, and z. And then I need to plug in there. Okay, now, what we need to understand here again is this. We are saying that time, it is in seconds. So I'm going to come here and say, this is going to be in seconds. I'm going to put them in brackets. So k is constant. Since I want to find the values of x, y, and z, I can ignore k for now. Okay, so I know that this is this m, it is the mass. Mass, it is in kgs. So I'm going to put this. Then the power there, it is the x. Okay, then when it comes for the length, we know that length, it is in meters. Okay, so I'm going to put m, meters, and then I put the power, which is y. Then g, we know that g is meter per second squared. Okay, so I'm going to come there and say, this is going to give me meters per second. If I say meters per second squared, it's the same as meters per second squared. It's the same thing. Okay, so that is what we're going to have here. We're going to have a squared there. Then the power there, it is z. Okay, but remember we said that where there is s, meaning seconds, we are supposed to replace it with what? With the t. Then what I'm going to do now here is this one I'm going to replace it with t. Okay, so this is to the power 1, as we can see there. Then this kgs, it is in mass. We say that this is going to be m, so to the power what? To the power x. Then the mass is length. Sorry, I mean this length, it is L. To the power what? To the power y. Then when it comes for this part here, we have two things. We have got the meters. So that meters, I'm going to put it what? I'm going to put it in this way. Okay, I have it is length, then I divide it by what? By the time, which is t. Now I have to square it. I have to square it by what? 2. Now, as we can see that everything is raised to the power what? Is raised to the power z. Okay, so I can create space. The reason why I'm doing this, I want us to find the value of x, y, z. Okay, so from here now I can say that this t raised to the power 1 is going to be equal to, we have the m raised to the power x, and then we have what? We have the l, which is the length, raised to the power y. What else do we have? Then we have also the length. Now, when we have something like this, we have l divided by t. This is the same as I can say it's l. So this is squared. It's l times t to the power negative 2. So what I'm going to do now here is I'm going to say that this is going to be my l raised to the power z. Then I also have t there. Now that t is raised to the power z, but we have 2. So this is going to be now negative. So it's going to be negative 2z. Okay, that is very important. Now from here we can find the values of x, y, and z. So we can see we have common things here. We have, so I can say that to the power 1 has to be equal to, we have m. Now this has to be the capital M to the power x. So we have L and L. This L and L is going to give us one common thing, which is going to be L. Now when the bases are the same, we add the power. So it's going to be y plus z. Okay, and then we have t raised to the power negative 2z. Now from here we can compare the left hand side and the right hand side. This part here we don't have x, meaning that x value is going to be 0, because this part we don't have anything. Okay, so we don't have anything, meaning that it's the same as we had m to the power 0. So m to the power 0, it is 1. So we can't put 1, we can't put the m here. That's why if there is nothing this side, we are comparing this part here to the left hand side. So here, as we can see that x is going to be equal to 0, because there is nothing here. To the left hand side, there is nothing for m. Okay, so x is going to be equal to 0. Then we are going to say that the L, we don't have L, so it's going to be L, x plus z is going to be equal to 0. Then when it comes for t, we have t this side. This t is to the power 1. Okay, so it's going to be negative 2z is going to be equal to 1. Therefore, z is going to be equal to negative 1 over 2. Okay, now since z is equal to negative 1 over 2, we can plug in the value of z to say it's going to be this, to find the value of y. So it's going to be y is going to be equal to half. Now after finding these values, these are very, very important. Now we are going to go back to our original equation where we talked about this. This is the original equation I'm talking about. Okay, so I'm going to get rid of this. Okay, I'm going to get rid of this. Our formula is going to be in the form of the t is equal to k, then we have m raised to the power x, l raised to the power y, g raised to the power z. So we plug in now the values of x, y, and z. Okay, so we have t is equal to k, we have m. What is the value of x? Is 0. And then we have l. What is the value of y to the power y? Y is 1 over 2. Okay, times we have g. Z is negative 1 over 2. So it's negative 1 over 2. Now we can see that any number to the power 0 is 1, meaning this part here is going to give us 1. So we're going to have our period is going to be equal to k l to the power half times g to the power negative half. Now we know that if we talk about to the power negative half, meaning this is the same as k l to the power half times 1 over g to the power half. It is the same thing. So if that is the same thing, then we can say that let's create space this side. We can say that this is going to give us t, k, and then we have L raised to the power half divided by what? G raised to the power half. So raised to the power half, if I have the square root of L, this is the same as L to the power half, meaning that this, I can put it in the square root and I can say that t is going to be equal to k the root of L divided by the root of G. So since we have got the root on top and the root down, meaning that we can simplify this and say k is going to be equal to the square root of L divided by, or here is not, here is supposed to be just k, it's going to be like this, meaning that this is going to be our expression for the period. Now k in this case is constant, so we have t is going to be equal to k the square root of L divided by G. Now looking at this expression, k is constant. Now the period of the pendulum is given by this formula. This is the Liu formula for the period of pendulum. So in this case, k is 2 pi. So that's why we are putting k to show that k is what? Is constant. Sometimes in some other question they can even tell you to say that k, maybe they can give you any value to say k is equal to 2 pi, meaning that you replace where there is k with 2 pi. So in this, like in this question, this is the answer. So it is t is equal to k the square root of L over G. Okay, so we have the next question. They are saying check the correctness of the expression. So we have to check if the units, they match a left hand side and the right hand side. Okay, so what we normally do here is we ignore the constant. So we're going to ignore the constant. So what we are going to do is we are going to start getting, we are going to compare on using this. So we know that when it comes for this m, it is mass. So mass is in kgs. Okay, velocity is just basically meters per second. Now I have to square it. Has to be equal to, this side we have got the kg, which is mass. The g is meters per second squared, and then h is in meters. Now using, according to the rules of dimensions, where there is kg, we have to put mass, m, capital M, then we put it like this. Then where there is the mass, is going to be length. Okay, now this to the power 2, I'm going to put to the power 2 divided by s is the second, so it's going to be time, then to the power 2. Okay, this has to be equal to this part here. We are going to have, this is going to be the mass, then we are going to have the mass, which is the length, sorry, the meters, which is the length. Then we have got the t squared, so I'm going to put it like this. Then I raise it to the power 2 times this is going to be the length. Now from here, what we have to understand is that we can rearrange this and say this is going to be the mass, then this is going to be the length to the power 2. This t, I can put it here, and then it's going to be to the power negative 2. Has to be equal to, it's going to be the mass. We have the length and length, you're going to get length squared. Then we are going to have also t to the power negative 2. Okay, to the power negative 2. So now they want us to check. We have to check to the left and the right hand side. So as we can see, this part here, the mass is raised to the power 1. So if it is raised to the power 1, we can now check. Let's now check the units. What do we have? So we have this to the power 1. This side we have to the power 1. Then the next one we have this to the power 2. This to the power 2. We also have the next one, which is this to the power negative 2, the t to the power negative 2, meaning this is dimensionally correct. Okay, so this is how we check. Now let's go to the next question. The next question is saying the velocity v of a particle at a time t is given by v is equal to, we have been given the formula, which is v is equal to at plus b divided by what? t plus c. Now, they want us to determine the dimensions of a, b, and c. Now, when it comes for any formula, any expression, when we want to determine the dimensions, what we normally do is this. We only, according to the rules of dimension analysis, we only compare this with this only, and then next we have to compare again this part here with this. We don't get the whole expression, no. So we are going to compare the v with at. Again, we are going to compare the v with b over t plus c. Then we find the dimensions of a, b, and c. So let's start with the first one. Okay, so the first one, as we can see, we are going to compare the v with at. So we want to find the dimensions of a. Okay, we know that the velocity is in meter per second. Okay, this is going to be equal to, the a is the one we are trying to find, the t is in seconds. So we know that the dimensions of meters is length. Then the dimensions of seconds is t. Okay, then this is going to be, it's going to be equal to a. This is going to give us t. It is the second. So we can divide both sides by what? We can divide both sides by the t. So we're going to have a is going to be equal to the L. Then we have, I can just put it like this. We have t. Then we also have divided, so it's the same as, I can just put it in this manner. Then I say we have, or let me put it in this way. Okay, let me put it in this way so that it should not confuse that. We can just say this, we do times the reciprocal of, is going to be 1 divided by t. Okay, so we're going to have 1 divided by t. What are we going to have? We are going to have 1 divided by this. So we can see that this part here and this, they will cancel. Then this and this, we are going to get, this part is going to give us t squared. This part is going to give us t squared. So our a is going to be, it's going to be the L. Now to put this one into, we can put it like this. Then we put the power -2. Meaning I've removed it in the denominator, I've put it in on numerator. Then that's the reason why I put -2. So meaning this is the dimension for a. Okay, and for sure we can see that this is correct, because if we check here, we have this. We have the velocity as meters per second. In short, the velocity is meters, which is L. We have this t to the power -1. So we know that if a is this, if a is L, then we have t to the power -2. T is seconds, we have t, which is just to the power 1. So we know that this and this, we are going to get -1, which is correct. So it's going to give us the same, this part and this part. So now let's go to the next one. To get the next one, what are we going to have now? We are going to have, the next part, we are going to get the v alone and the b over t plus c. Now from here, what we have to understand is that we can cross multiply, and then it's going to be vt plus vc is going to be equal to b. So we want to find the value, the dimensions of b and c. So what we have to understand is that we said we compare one by one. So we're going to compare b with this, again b with this. So the first thing which we're going to compare is going to be b is going to be equal to vt. So I know the v. Okay, I know the dimensions of v. We know that v is meters per second. Okay, the t is in seconds. So at this instance, we can see that this and this will cancel, and then b is going to be equal to the meters. So we know that meters is just basically the length, meaning this is the dimension for b. So to get the dimension for c, Now we are going to compare the b. We're going to say that it's going to be b is going to be equal to, we have now vc. So we know that the dimension for b is length. Then v, we know that it's meters per second, but we know that meters per second, it is the length. Then we have per second, so it's going to give us length. Then we have the time to the power -1. So I have c. My goal is to find the value of c. Okay, so I can divide both sides by length, then t to the power -1. Same applies to this, then t to the power -1. Okay, so what we are going to have there is we are going to have c is going to be equal to the length and length will cancel. We are going to have 1 on top divided by t raised to the power -1. So now this raised to the power -1 is the same as 1 over t. So meaning that this is going to give us something like this. It's going to give us c is equal to we have 1 divided by 1 over the t. So which means that this is the same as if I say it's going to be 1 times 1 t over 1. So it's going to give us just t. So the dimensions of c is just t. So this is how we can solve this question. Okay, so let's go to the next question. The next question is saying Mr. Mansa was trying to demonstrate an experiment. He realized that the force F acting on a body with which was moving in a circular path depends on mass of the body m, velocity v, and the radius r of the circular path. He then tells you to obtain an expression of the force using your knowledge of dimension analysis. So taking the value of k to be equal to 1. So remember, we want to get the expression for force. So as long as you want to get an expression, the first step which you have to take is you write force is going to be the proportion to what? The things which have been given is the mass, the v and r. Now from here, where there is this, just replace it with equal to k. So where there is proportion, I'm going to replace it with this part. So I'm going to say that this is going to give me equal to k mvr. Now the things which you have here, just raise to any letters, and then you find the values of. So I'm going to say this is going to be x, y, then this is going to be z. So my goal is to find the value of x, y, z. Then I plug in there, and that would be my formula. So what I have to understand is that force, I'll start from here. So I'm going to ignore them, meaning that I have x, y, z. I'm going to ignore the k for now because k is constant. So force, I know that it is force, we know that it's Newton, but remember we are only, according to dimension analysis, we are only considering the mass, the length, and the time. So we know that in 1 Newton there is 1 kg per second squared. Per meters we have, okay, force is mass times acceleration. So we know that mass is kg, then acceleration is meters per second squared. Meaning that where there is force here, we are going to put what? We are going to put kg, and then we are going to put the mass, everything divided by second squared. Okay, then this is going to be equal to the mass. This is the mass, okay, which is kgs, and then the v is meters per second, and then we have the r. The r is the radius, which is meters. Okay, now from here what we have to understand is that the kgs, remember that the kgs, when it comes for dimension analysis, is going to be the mass. Oh, yes, then we put this, then the length is L. This is on the denominator. To put it on the numerator, I'm going to put it is time. Now it has to be to the power -2. this has to be equal to, we know that this is to the power x, this is to the power y, this is to the power z. So we are going to say that kgs is meters to the power x, then this is length to the power what? Y. But then this is going to be time to the power, this is going to be time to the power -1, but now because it is raised to the power y, it's going to be to the power -y. Then we are going to have now m, which is length, okay, to the power z. So now I can get rid of this to create space. Now from here, what we have to understand is that we compare now. But before we compare, we can see that we have got common things. So we have m, this m is raised to the power 1. Then we have length. Length is also raised to the power 1. Then we also have the time. Time is raised to the power -2. We are done. Has to be equal to, we have this part, we have mass, which is capital M. So that mass is raised to the power, x. Is raised to the power x. So if this is raised to the power x, then the next one we have length, we have two lengths, length and length. So if the bases are the same, we add the powers. Okay, so what we are going to have there is, we are going to have the y plus z. So we're going to have y plus z. Okay, after adding that, we have remained with 1, the t. So we have our t, which is going to be t raised to the power what? -y. We can now compare the powers. Okay, -y. We can now compare the power. So I can get rid of this. I no longer need this. The only important thing is this part here. Okay, so I can now say that my x, this part, I have got x. Now I compare it with this one. So m, the power there is, so x is going to be equal to 1. Then the y, we have got y plus z is going to be equal to, we have got L there, which is going to be 1. Then -y is going to be equal to -2. Therefore, y is going to be equal to 2. So if y is equal to 2, meaning that in this formula, we can see that y is 2 plus z is going to be equal to 1. So meaning that z is going to be equal to 1 minus 2. So our z value is going to be -1. Okay, so now after finding our values of x and y, x, y, z, so we can now continue and plug in the values. We have got k, so we have got the m. So the m, the power for m, we had x, so the x is 1. Then the v, the power is y, so the y is 2. So we're going to say v, okay, we have v to the power y, so y is 2. So I'm going to put 2. And then the r is z, the power for r is z. So what is the z? The value for z is -1. So now we can see that we have f is going to be equal to k. We have got m v squared. The r is raised to the power negative. As long as it is to the power 1, it's the same as it is down here. So I can say that this is going to be down here. So we have been told that the k value is 1, meaning that I'm going to say that the force is going to be equal to, the k value is 1, so 1 will not affect anything. So we're going to have this. So as we can see, this is going to be our expression for the force. Now, this is the centripetal force. This is the formula for centripetal force. Okay, so we go to the next question. The next question is saying, okay, so this question was, Newton's laws of universal gravitation is represented by, so the gravitational force is represented by F is given by G, the capital M, the small m, divided by r squared. Okay, so this was the question, to say Newton's laws of universal gravitation is represented by this formula, where the gravitational force are masses. We have got the masses here. Then we also have the length, which is the radius. Okay, so they want us to find what are the SI units of the proportion constant. They want us to find the SI unit for the G. Okay, that was the question. Okay, So we know that the masses, they're going to be in kg. So it's just a matter of us making g as a subject of formula. So we're going to cross multiply. So this is the same as we have f is going to be equal to g capital M small m divided by r squared. So it's going to be g capital M small m is going to be equal to f r squared. We divide both sides by m small m small m. So our g is going to be equal to, we have the f r squared, everything divided by m capital M small m. So now we want to find the units for g. So we're going to plug in the values. We know that the SI unit for force, we're not going to put newtons. The reason is simple. When it comes for dimension analysis, so it's going to be the kg meter per second squared, because force is equal to mass times the acceleration. So in 1 newton there is 1 kg meter per second squared. Okay, so it's going to be this is going to give us the F is going to be the kgs. We have the kgs, then we have meter, then we have square. Then this one we are going to have m times m, which is going to give us m squared. So it's going to be, so this is the same as kg meter, everything divided by s squared, divided by, we have this now, it's going to be m squared. Okay, so from here we can now simplify this and we can say that g is going to be equal to, we have what? We have the kgs. Okay, we have the kgs, so we are going to have okay, we are going to have the mass. We have the mass. So what we're going to have here is this. I think here we need first, let's first deduce it from here. We are saying that this is going to be m to the power 2. Okay, so it's going to be g is going to be equal to it's going to be m kgs, then we have m to the power what? We have seconds. Okay, oh, we have the meters. So this is the mass. It's not, it is the mass. So we have the kgs. Okay, the formula was like this. Let's start from here. It was fr squared, and then it was mass and mass. So it is kgs. So we have this. The f is kgs per, is kgs meter. Then we have this. So this part here down there, the radius is now in meters squared, but it's because it's squared, so we have to square it. So this is going to be kgs times kgs. Okay, yeah. So kgs times kgs, we're going to get kg squared. So we're going to have g is going to be equal to, we can cancel 1 kg there. This kg and this one will go. So we're going to remain with 1 kg. So we can say that meters and meters is going to give us m to the power 3. Okay, and then we have this to the power this, then we have kgs. So we can see that this is going to give us m to the power 3 divided by this, then we have kgs divided by 1. So this part here is going to give us this. Okay, it's going to give us g has to be equal to m to the power 3 divided by s squared times 1 over kgs. So we're going to have g is going to be equal to m to the power 3, then we have everything divided by s to the power 2, then kgs. So meaning that the SI unit for g is you can write it and say is just basically g is going to be m to the power 3 per kg s to the power 2. So these are the SI units for what? For g. Okay, so this is how we get to understand dimension analysis. Thank you.